Welcome to another episode of Teaching Math. In today's video we'll be starting on Chapter 5, my all-time favorite. That's because Chapter 5 is all about Pythagoras' Theorem. In paragraph 5.1 I will refresh your memory about squares, square roots, and I will start on the basis of the theorem. So, without further ado, let's start the chapter. A few things before we can really start. First of all, in many exercises you will need to round off your answer. As we will be working with square roots this chapter quite a lot, many answers will have an infinite number of decimals. So in many exercises you will be asked to round off your answer to 1 or 2 decimal places. So 34.527 rounded off to 1 decimal place will become 34.5. And round off to 2 decimal places, we receive 34.53. When rounded off to the nearest integer, meaning a whole number, we receive 35. Make sure you know how to round off. 0 to 4 is low, 5 to 9 is high. The second point is using the squares and square roots. You can always use a calculator in this chapter. So there's no need to calculate the square of 3.4 mentally. But if I do see you using your calculator for calculating the square of 6 or the square root of 16, I'll be severely disappointed. You should be able to memorize the squares up to 20 and their corresponding roots. So, with that out of the way, let's start the paragraph in earnest. In this chapter, we'll be talking about right-angled triangles. A right-angled triangle is a triangle where one angle is a 90-degree angle. The Greek mathematician Pythagoras was the first to prove that when a right-angled triangle is enclosed by 3 squares, the sum of the smaller squares is equal to the largest square. As you can see in this example, the yellow square is 9 units. The red square is 16 units and the blue one has a total of 25 units. In math, a statement that has been proven to be true is called a theorem. As Pythagoras was the first to prove this statement, we call this property of a right-angled triangle the Pythagoras theorem. Now that we've discussed what a theorem is, let's take a closer look at a right-angled triangle. This here is triangle ABC. With angle B equal to 90 degrees. The side opposite of the right angle is called the hypotenuse, or longest side. The other sides form the right angle and are called the legs. And this is triangle KLM with angle K equal to 90 degrees. That means that KL and KM are the legs and LM is the hypotenuse of the triangle. Understood? Perfect. Then on to the last part of the paragraph, writing the theorem for a triangle. For triangle PQR, the theorem states that the sum of the areas of both squares on the legs is equal to the area of the square on the hypotenuse. As angle Q is 90 degrees, that means PQ and QR are the legs and PR is the hypotenuse. Square 1 with side PQ has an area of PQ times PQ, so PQ squared. Square 2 with side QR has an area of QR squared. And square 3 with side PR has an area of PR squared. This means that Pythagoras' theorem for this triangle is PQ squared plus QR squared is equal to PR squared. Of course, we can do this without drawing extra squares. For triangle DEF with angle E equal to 90 degrees, the theorem is DE squared plus EF squared is equal to DF squared. And just so you know, if you were to switch DE squared and EF squared with each other, no problem. As long as the hypotenuse is at the end of your line, it's okay. And this here is triangle GHI. with angle G equal to 90 degrees. The correct theorem for this triangle is GH squared plus GI squared is HI squared. One final triangle, triangle STU with angle T equal to 90 degrees. Do you already know what the correct notation for Pythagoras' theorem is? If you thought ST squared plus TU squared is equal to SU squared, then you were correct. And with this, we've reached the end of this paragraph. You now understand what the hypotenuse of a right angled triangle is and how to write down the Pythagoras theorem for a triangle. In the next paragraph, we'll be using the Pythagoras theorem to calculate the sides of a triangle. Be sure to practice your knowledge, and I will see you in the next episode. Bye bye!